Hi, welcome back to ITC561. Today we're going to look at topic 6, designing for the cloud. Now, personally, I think this is probably one of the most interesting and challenging topics in the whole subject. It's an area that really gets me going. I mean, I've been an architect for quite some years, and an application designer before that. So I come at this from both directions, and I find it fascinating. So also realistically, we probably should make this really two separate subjects. One for those cloud application designers, another one for cloud architects. But in order to do either design job, you need to have some idea of the issues that must be dealt with in cloud design. And that's what we're covering in this whole subject. All of these different issues and problems that you've got to look at. So what we'll do in this topic, we'll look at both the architectural and the application design approaches to design. So you get a bit of an understanding for both of them. So from an architectural point of view, we're going to concentrate on the use of the AWS well-architected framework. Now, this we're going to use as just an exemplar of how to approach architectural design for the cloud. It is not the only way to do it. As you'll see, Google and Azure have similar but different ideas. And so what we really want to look at in this topic is what are the principles that underlie this design. If you're trying to design for the cloud, what are the principles you should work to, right? And these principles really are applicable to any public cloud that you work in. So if you can pick up and hold on to these principles, this will make your professional life so much easier. It'll, as a side effect, it'll also make designing for your assignments somewhat simpler as well. Readings. There is a huge load of readings in here, and if you've had a look at topic 6 already, you're probably starting to quail just a little bit. And what I've done here is I've given you some links to the AWS reference architecture site as well. And so I've also put in a link to the standard architectures that NIST has developed to be used on AWS. And these are really worth a bit of study. But I've split the readings into two main sections, the AWS well-architected framework and the different pillars that make up that framework, and then a series of reference architectures and patterns. Now, let's be totally realistic. You don't need to read all of these between topic 6 and topic 7, right? It's impossible. You're not going to do it. So don't try. Scan the well-architected framework so you get a feel for it, how it works. Scan some of the pillars of the well-architected framework. If you want, go into the reference architectures and things to have a look at how Azure has done it, or GCP has done it, or somebody else has talked about it. But at this stage, it's scan. You're not going to be asked great questions around this in an exam or in any sort of final assignment. You are going to be expected to know principles, right? So that's where you need to concentrate. But this stuff will be invaluable to you in your professional career for your own personal professional development. So whatever you do, make sure you take copies with you. Okay, the design principles, and there are a number of design principles we'll go over here, and these have been developed over time by a number of different cloud architects. You'll see most of them in the AWS well-architected framework, and these bear quite close consideration. These are principles you'll use continuously in your professional career if you're doing cloud design, either architectural design or application design, and they can kind of come in handy for your assignments as well. Think about the way that you'll use these in a cloud design. Right. One of the things that makes cloud design so interesting is that from that design perspective, you're no longer tied to the technology stack that your enterprise has invested gazillions of dollars in. I found this personally quite liberating once we started to move from the technology stack that our department had invested loads of money in into the AWS cloud, because suddenly I could say, okay, let's not use that. We don't need to. We're going to use this architecture because this will actually fit the needs of the problem so much easier. You can now use technology, the best technology that's available to suit your business requirements, and you don't need to bring in extensive and expensive business cases to justify it, right? Brilliant stuff. This is where it really starts to pay off for you. The one piece of advice I'd give you in your cloud design is always try to concentrate on creating that design so that you are implementing a service for a user, not a server for some infrastructure. So as we've seen in a lot of cases already, you don't need a server in order to complete services and provide them in the cloud, right? So really think about that. create your design to implement services. We'll also look quickly at serverless application design, and we'll cover this mainly in the lecture. But some of the principles here are, that you should be speedy, simple, singular. So you do short, concise, single-purpose functions. You use concurrent requests for scalability. You share nothing between any of these functions. Remember, you're in the cloud, so that runtime environment and the underlying infrastructure are quite short-lived. So you can't guarantee you're going to have temporary storage there for any period of time. So don't try to share things. Complete and pass. Right? Assume there's no hardware affinity. You can't write something to exist on a particular bit of hardware because the infrastructure could well change at any time. And use events to trigger transactions. Now this looks quite simple, and there are more which will be covered in the lecture, but it's just a little bit more difficult to actually get your head around designing that so that it works properly. And so from an application design point of view, you're going to have to do a little bit of work around how do I design that? How do I put together a whole series of functions that are short, simple, singular, can do concurrent requests, don't share anything, have no hardware affinity, and use events to trigger other things in another function. Not impossible, and certainly most worthwhile. So how does this all fit into your study? Well, firstly, you meet a couple of learning outcomes here. Compare and evaluate the ability of different cloud computing architectures to meet business requirements. That's what you do as an architect. You're comparing this, looking at architectures and evaluating them to meet business requirements all the time. It's one of your daily tasks. You're also evaluating a set of business requirements to determine suitability for a cloud computing model. So it's the other side of it. You're looking at the business requirements and say, can I do this in the cloud? Is there something here that stops me from doing it in the cloud? Or can I break this and move this around in such a way that I can meet the requirement and yet complete it in the cloud? So again, these are things that are common architectural requirements. And these, once you get these learning outcomes in place, you have achieved a fair bit towards becoming a good cloud architect. So where this topic will be of great assistance to you, of course, it'll help you complete assignment 4, where amongst a lot of other things that you've got to do in assignment 4, you've got to develop a report to the board that says, describes the cloud architectures you would employ to assist DSI, in this case, to meet the board's multi-cloud strategy. And of course, then the final exam, you may well be questioned on this knowledge. And again, I would stress to you, this is another set of knowledge that you're going to constantly use in your workplace. So this is kind of really important stuff. There's a few really important topics in here that bear close consideration and going back to. Remember as well, as I said, that the list of readings there that you need to pull out and keep so that you've got them for future professional development. So don't forget to get hold of those. Again, if you've got any questions, start raising issues on the discussion board. Raise questions with your lecturer, and we'll get the answers all sorted out for you. In the meantime, I hope you enjoy this topic. This is personally one of my favourites, and I quite like it. See you again shortly.